Tiny plastic particles, previously unaccounted for, can be found in bottled water in the hundreds of thousands. Greetings and salutations to everyone. In today's video, we will be delving into the fascinating subject of recent advancements in technology that have allowed scientists to successfully identify and quantify nanoplastics in bottled water for the very first time. These nanoplastics are the offspring of microplastics that have undergone further degradation, becoming so minuscule that they can easily pass through our digestive system and respiratory organs, entering our bloodstream and ultimately reaching vital organs like the heart and brain. Astonishingly, the researchers discovered that, on average, a single litre of bottled water contained an astounding 240,000 visible plastic fragments, surpassing previous estimations by 10 to 100 times. This groundbreaking study underscores the urgent need for additional investigations into the potential impacts of nanoplastics on both human health and the environment. Without any further delay, let us now embark on our in-depth discussion. There's a growing apprehension in recent times regarding the widespread presence of minuscule particles called microplastics, which can be found in various locations across the globe, ranging from polar ice to soil, drinking water, and even food. These particles are formed as plastics gradually disintegrate into smaller fragments and are being ingested by humans and other organisms, with uncertain consequences for both health and the environment. A significant area of study revolves around bottled water, as numerous studies have revealed the presence of tens of thousands of identifiable microplastic pieces in each individual container. With the aid of recently improved technology, scientists have ventured into a previously unexplored domain, the obscure realm of nanoplastics, which are the offspring of further degraded microplastics. In a groundbreaking achievement, they have successfully quantified and classified these minuscule particles in bottled water. Their findings revealed that, on average, a litre of water contained approximately 240,000 identifiable plastic fragments, surpassing previous estimations by a factor of 10 to 100, which predominantly focused on larger plastic sizes. Recently, the journal Proceedings of the National Academy of Sciences published a newly conducted study. Unlike microplastics, which are larger, nanoparticles are incredibly small and have the ability to penetrate the bloodstream and reach organs such as the heart and brain, bypassing the intestines and lungs. These minuscule particles can even enter individual cells and cross the placenta, posing potential risks to unborn babies. Researchers in the medical field are actively investigating the potential impacts of nanoplastics on various biological systems with a sense of urgency. We used to have no knowledge about this particular region. It was completely unknown. The assessments on toxicity were merely speculative, as we had no concrete information, explained Bejan Yan, an environmental chemist from Columbia University's Lamont Doherty Earth Observatory and co-author of the study. Now, a new opportunity has emerged, allowing us to gain insight into a previously unexplored realm. The annual global production of plastic is rapidly approaching a staggering 400 million metric tons. Shockingly, over 30 million tons of this plastic waste is irresponsibly discarded into our waterways and land each year. Furthermore, numerous plastic-based products, such as synthetic textiles, continuously release tiny particles into the environment during their use. Unlike organic matter, plastics do not decompose into harmless substances. Instead, they fragment into smaller and smaller particles while maintaining their chemical composition. In fact, there is no theoretical minimum size to which these particles can be reduced. Fragments that fall within the size range of 5 mm to 1 micrometer are classified as microplastics. To put it in perspective, a micrometer is equivalent to 1/1,000,000th of a meter or 1/25,000th of an inch. For reference, the width of a human hair is approximately 70 micrometers. Nanoplastics, on the other hand, are particles that are smaller than 1 micrometer and are measured in billionths of a meter. The public concern surrounding plastics in bottled water gained significant traction following a study in 2018, which revealed an average of 325 particles per litre. Subsequent studies further magnified this figure, indicating that the actual number of particles was likely much higher than initially calculated. Scientists speculated that there were additional particles below the 1 micrometer threshold, marking the boundary into the realm of the nano world. According to Naixin Qian, the lead author of the recent study and a chemistry graduate student at Columbia University, individuals have devised techniques to observe nanoparticles. However, they lacked comprehension of the nature of what they were observing. Qian pointed out that prior research could offer general approximations of the mass of nanoparticles, but was generally unable to quantify individual particles or differentiate between plastics and other materials. Utilizing stimulated Raman scattering microscopy, a method co-invented by Columbia biophysicist Wei Min, the researchers in the new study employed 2 lasers to examine samples, specifically targeting 7 frequently encountered plastics. By tuning the lasers to resonate with specific molecules, they were able to generate data and develop an algorithm to interpret the findings. According to Min, detecting is one thing, but understanding what you are detecting is another. In the United States, 3 well-known bottled water brands were subjected to rigorous testing by researchers. The brands were not disclosed. The analysis focused on plastic particles as small as 100 nanometers. Astonishingly, each litre of water contained between 110,000 and 370,000 particles, with nanoplastics comprising 90% of the total and the remaining being microplastics. Furthermore, the researchers identified the specific types of plastics present and documented their shapes, which could have significant implications for biomedical studies. Polyethylene terephthalate, commonly known as PET, emerged as a prevalent culprit, which is to be expected considering its widespread use in water bottles. This material is also utilized in the production of bottled sodas, sports drinks, and various condiments like ketchup and mayonnaise. The introduction of PET particles into the water supply likely occurs when the bottle is squeezed or subjected to heat, causing small fragments to detach. A recent study proposes that the repeated opening and closing of the bottle cap, along with abrasion, contribute to the influx of minuscule particles into the water. In a rather ironic twist, polyamide, a form of nylon, outnumbered PET in the study. Beijing noted that this is likely due to the presence of plastic filters, which are intended to purify the water prior to bottling. The researchers also discovered other prevalent plastics, such as polystyrene, polyvinyl chloride, and polymethyl methacrylate, all of which are utilized in different industrial applications. It is disconcerting to consider that the researchers' investigation into 7 specific types of plastic only represented approximately 10% of the total nanoparticles discovered in the samples. The remaining nanoparticles remain a mystery, leaving the researchers uncertain about their composition. If all of these unidentified particles are indeed nanoplastics, their quantity could reach into the tens of millions per litre. However, it is also possible that these particles could be composed of various other substances, highlighting the complex nature of the particles found in what initially appeared to be a simple water sample. The authors emphasize the need for careful discernment when dealing with the presence of natural organic matter, which is commonly found in such samples. Expanding their investigation beyond bottled water, the researchers are venturing into the vast realm of nanoplastics. Min expressed the magnitude of this unexplored territory, emphasizing that while nanoplastics may not weigh as much as microplastics, their abundance is what truly counts. Size is not the determining factor, rather it is the sheer quantity of these minuscule particles that increases their likelihood of infiltrating our bodies. As part of their research, the team intends to investigate tap water, which has been found to contain microplastics, albeit in smaller quantities compared to bottled water. Beijing is leading a project that focuses on the study of microplastics and nanoplastics that enter wastewater during laundry cycles. According to his findings, millions of these particles are released from synthetic materials present in various clothing items during a 10-pound load. To combat this issue, Yan and his colleagues are developing filters to minimize pollution from both commercial and residential washing machines. Additionally, the team will soon analyse particles found in snow collected by British researchers trekking across Western Antarctica. They're also collaborating with experts in environmental health to assess the presence of nanoplastics in different human tissues and investigate their potential effects on development and neurological health. The presence of such a substantial amount of this material is not entirely surprising, remarked Qian. The concept is that as things decrease in size, their quantity increases. The collaborative research effort involved the participation of Xin Gao and Xiaoqi Lang from the chemistry department at Columbia University, Huipeng Deng and Theodora Maria Bratu from Lamont Doherty, Chixuan Chen from Columbia's Mailman School of Public Health, and Phoebe Stapleton from Rutgers University. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.